And let's get started. So I sent y'all the following. I sent this file. I know that half of you won't print it out, but I sent you this file, and that is called the normal curve with the z-scores as well as the empirical rule. And the empirical rule, let's go ahead and the empirical rule will be on your Unit 1, Unit 3, and Unit 4 test. So if you choose to ignore the empirical rule, then you probably fail the class. Okay, so I want you to remember the empirical rule. The empirical rule states that the mean is in the middle. You add the standard deviations on the right. You subtract the standard deviations on the left. The normal area is 25%, 95%. That's your normal area. Your unusual area is between the second and third standard deviation. And your outliers are outside 3 standard deviations. Now, there are about 3 or 4 questions on the test that are nothing but empirical rule. You're not going to be able to use your calculator, and you're not going to be able to copy off of each other because the test is totally different. Okay? So you're going to have to know the empirical rule to do those 3 or 4 problems. Okay? So if I give you the mean is equal to 50, and the standard deviation is equal to 10, then you will put 50 in the middle, and this will be 60, 70, 80, 40, 30, 20. And then you will answer the questions on the test or the homework according to what they give you. And I think we went over the empirical rule Monday, did we not?
We did.
Okay. And I think it's on page 129, I'm not sure. But that is the empirical rule. And yes, I'm going over it twice because it's important. And I want to make sure all of you have that information. The 5-number summary. 5-number summary is based on the mean, the first quartile, the second quartile, the third quartile, and the max. If I give you 10 numbers, 15, 20, 25, 25, 28, 30, 32, 37, 40, and 41. If I give you those 10 numbers on a test, what is that noise I keep hearing? I mean, it's not somebody talking, it's not somebody tapping or something. 15 is your min. 41 is your max. The second quartile is the median. And 10, so we count 1, 2, 3, 4, 5. And 28 plus 30 is 58, and that would be 29.5. If I did that right. Somebody take the average of 28 and 30, please.
It's 29.
Is it 29.5?
I think it's 29.
Okay. And that's in the middle right here. You got 5 numbers above it. So 25 is your and 37 right there. Draw your box plot. This is 15. This is 41. Mid-range is, let's say 15 plus, that'd be what, 56? And half of 56 is 28. Y'all check my math. And then you graduate the number line. 15 to 28, 13, half of 13 is 6. So that'd be 21. This will be 34. 3, 18, 24, 31, 37. And then your 25 goes right about here. And your 29 goes about here. And your 37 goes about right here. And that is your box plot. And that's a little review over what we did Monday. Empirical rule and 5-number summary. And this looks like, here's the middle. Looks like it's a little bit skewed left because most of your data is on the right. So if most of your data is on the right, skewed left. Okay. So that's what we went over Monday. Everybody good?
Yes, sir.
All right, now Z-scores. So I want you to write what I'm putting on the board right now. I blew it up. Hopefully y'all can see it. It says the height of Lyndon Baines Johnson, LBJ, is 75 inches. And I'm going to write it so you can see it for those that sit in the back of the room. I don't know what y'all's projector looks like. I don't know what your screen looks like, so I don't know what you can see and what you can't see. So I'm going to write it down here below it. Okay, LBJ, Lyndon Baines Johnson, is equal to 75 inches. And president's, the average or the president's height is 71.5. And a standard deviation of 2.1. Shaq is 85 inches. And the mean for basketball players is 80 inches. And the standard deviation for basketball players is 3.3 inches. And the question asked, and I'm going to put this in red, the question asked Who is relatively taller? Well, anybody with two teeth in their head can tell you that Shaq is taller. That's not what the question's asking. Question is asking who is relatively taller. Can somebody tell me what relatively, I don't know if it's got an E in it or not. Relatively, what does that mean? Anybody?
Based on the rest of the population that you're measuring?
Based on their own population, yes. Based on own population. So, what is the requirements for being president of the United States?
Maybe like 35 or something.
Okay.
Got an age requirement. What else?
Must be a U.S. citizen.
Must be a U.S. citizen. Is there any requirement on height?
No.
No. James Madison was 5'5". 5'5". And I don't know which one you're going to count on Franklin Delano Roosevelt. He was in a wheelchair. I don't know if you would count him as, you know, height. Which way would you count? When he's in his wheelchair or when he wasn't? So height is not a requirement. But what about being a basketball player? Does being tall, is that an advantage in basketball? Yes, it's an advantage. So LBJ is a big fish in a little pond. What is Shaq? He's a little fish in a what?
Big pond.
In a big pond. So who is relatively taller? Well, you're going to calculate what they're called the Z-score. The Z-score is what compares apples and what? Oranges. Excuse me. Apples and oranges. So the Z-score formula is X minus X bar over the standard deviation. Write that down. X minus X bar over the standard deviation. And I want you to calculate it for LBJ and Shaq. Go ahead and do that. Plug and chug. Plug and chug and find out the Z-score for each. So 75 minus 71.5 over 2.1. And then 85 minus 80 over 3.3. Somebody give me the Z-score for LBJ.
1.67.
All right, I'm gonna write that in. I'm gonna put that in orange. 1.67. And somebody give me the Z-score for Shaq.
1.52.
So we got to plot these on the table. Now, when you plot using Z-scores, when you plot using z-scores, the mean is equal to 0 and the standard deviation is equal to 1. So 0's in the middle. 1, 2, 3, -1, -2, -3. And we know that 95% of the population is going to be normal. And 10% are above 2 standard deviations is going to be unusual. And then past 3 standard deviations is considered to be outliers. So the closer you are to the outlier, the more ER you are. And that's what I tell students. I'm going to write that down in red. The closer you are to the outliers, the more ER you are. In this case, what is it asking? Who is relatively what? Taller. So that's the ER. In this case, who is relatively taller? So LBJ is 1.67, right? LBJ is 1.67. And Shaq is 1.51. So somebody tell me who is relatively taller?
OBJ.
LBJ. So the answer to this question, who is relatively taller, is LBJ. Is this a test question? Yes. Anybody have a question? Nobody has a question. I've covered the material so well, nobody has a question. All right, let's do another problem then. Let's do another. How many numbers did we have in our last problem that we did with mean, median mode, and all that stuff? How many numbers did we have? 7 or 10?
I think it was 10.
All right, how many?
10.
All right, let's do one with 11. Let's go to the spreadsheet. And let's do one with 11. So n is equal to 11. I want you to do the 5-number summary as well as the box plot. And I want you to do the normal curve and fill out the mean and the standard deviation. So let's go with ages 18, 19, 20, 20, 21, 24, 25, 26, 26. It says 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 30. All right, I'm going to give you 5 minutes. 2:25. 5 minutes to do everything you can, and I'm gonna make it big here in a second. Everything you can for these numbers. I'm gonna blow it up. Make it a little bit bigger. There you go. There's your numbers.
Like this, you. I can sit up and talk a little bit.
Okay, that's 5 minutes. Now, I will not ask you to do all this on a test at one time, but I will ask you to find all these little things on separate test questions. So I've already done a couple of things. I've already found the min and the max. Everybody should get that right on the test. If you get that wrong, please don't tell anybody because they'll be getting to wonder if you're sentient. The median is the second quartile. And let's go ahead and find the mean. I'm going to add up all these numbers. And I'm going to divide by 11. What'd y'all get? I got 22.455. Thumbs up?
Yeah.
Good. So I'm going to color that green because that's important. And I'm going to color the median green. Mode, I really could care less. But 18, 20, and 26. Don't check me. I think that's the mode.
Agreed.
Range is equal to 30 minus 18. Mid-range is equal to 30 plus 18 divided by 2. Variance, this is x, so we need x minus x bar because if you didn't write it down, the variance is equal to the summation of x minus x bar, quantity squared, divided by n minus 1. So that's about the third time I've written that down, but hopefully y'all wrote it down by now. So I'm going to do x minus x bar. And that's going to be equal to this number minus this number. And F4. And copy that down. And then we square that function. So that's going to be x minus x bar raised to the second power. And that's going to be equal to this guy raised to the second power. And that basically makes all of them positive. And add those up. So for my variance, I have a numerator of 156.7. So 156.7 divided by 10. Please do not put that in a calculator. Move the decimal one place to the left. 15.67. So the variance is equal to this number divided by 10 and raise it to the 0.5 power. And there is your standard deviation. So I can take my empirical rule now. My mean, sorry, my, here. My mean is well, my computer. There. My mean is 22. I'm gonna put 22 because I don't want to have to fool with the decimals while I'm teaching. But you would use 22.455. And the standard deviation is equal to 4. So what you would do, you would take the 22 point whatever, and you'd put it in the middle, and then you'd add, it'd be 26 point whatever, and then 30 point whatever, and then 34 point decimal, blah, blah, blah. And on this side, 18, 18, and 14, and 10. And remember, these would be decimals. I'm just not doing decimals because I'd have to use a calculator to do them, and I don't feel like doing that right now. Okay? And you would, if asked, you would fill it in, and 95% falls within 2 standard deviations. So if you're given a question on the test or the homework, and all they give you is this, chances are they want you to do the empirical rule. You might want to write that down because there's 2 or 3 questions on the test that people just, they don't even do it. And all they had to do was draw a picture. And 2 standard deviations would be 14 to 10 and 30 to 34. And then the outliers would be above 34 and below 10. Now let's go to the 5-number summary. Five-number summary, you already got some of it filled out. Where is, how many numbers are above 21? How many numbers are above 21?
5.
And 5 is even or odd?
Odd.
So there, right there, is our first quartile. Now, if you had even numbers up here, if you had 6, you would have to do the middle 2 numbers. So this one is your bottom quartile, 3rd quartile. And now you're ready to draw your number line. And your number line is going to consist of your min of 18, your max of 30, and your mid-range of 24. Let's graduate it. So 18 to 24 is 6. Half of 6 is 3. That'd be 21. That'd be 27. This would be what? 18 to 21 is 3. 1.5 would be 19.5. 1.5 would be 22.5. 25.5. And 28.5. Now, how far should you graduate? Well, that's up to you. If you want to fill in between these, then you just keep going. But that's good enough to plot. Our first quartile is 19, and it's light blue. So 19 would be right about here. And then yellow is 21. And then 26 would be dark blue. And here is your box plot. And here's center. It looks like that the actual data is skewed right. Because all the data is left of center. Now, there's one more thing I want to talk about with the quartiles, and that is the interquartile range. So let me find the text 3. And you might need this for your standardized test because they do this and students don't answer the question because they don't know what the interquartile range is. So it might be important for you to write it down if I can find it. It's in your book. And this is the wrong book. I suck. It's the calculus book. Great. Pull up the calculus book and statistics. Y'all don't notice. Y'all ain't paying attention anyway, right? Oh, we ain't paying attention. All right. Give me a second to pull up the right class. Sorry about that. All right. Ebook. Chapter 3. 3.5. Now let's see if I can find the right page. And it's just subtraction. Interquartile range is just subtraction. But you get a multiplier and you multiply it and then you get the parameters for the left and the right. Here is the interquartile range. Write that down. It's right there. Interquartile range is the third quartile. Third quartile minus the first quartile. Write that down. The interquartile range is the third quartile minus the first quartile. And then you multiply it by 1.5 to get your lower parameter. You take first quartile and you subtract 1.5 the interquartile range. For the upper parameter, you take Q sub 3 and you add 1.5 the interquartile range. And I'll show you what this does. So I'm going to go back to the spreadsheet, and I'm going to find the interquartile range. And the interquartile range is the third minus the first. Now I'm going to do the lower parameter. That's going to be Q sub 1 minus parentheses this times 1.5. And then your upper parameter is going to be your third quartile plus the 7 times 1.5. And watch what this gives you. Basically, what this gives us is an 8.5 and a 36.5. So if you did not have the, if you didn't have the empirical rule, anything below 8.5 is called a what? An outlier. Anything above 36.5 is called an outlier. So this is another way of finding the parameters for your outliers. So when you're dealing with the interquartile range and you find in the lower parameter and the upper parameter, this is another way to find outliers. So now you've got the empirical rule, which told us that anything below 10 and anything above 34 would give us an outlier. This tells us anything below 8.5 and anything above 36.5, which is fairly close to what the empirical rule says. Let's just put that down here. The empirical rule says that anything below 10 and anything above 40 is an outlier. And you can see they're not that far off. But the test question may ask you to find the outliers with the empirical rule, or it may ask you to find the outliers with the interquartile range. So there's your two different methods of finding outliers. Question, right, complaint. Any questions? You know, y'all can ask questions. Y'all know that, don't you? It is not, you know, unbearable to ask questions. Okay. I don't want y'all to say I didn't offer to answer questions. So let's look at one of your questions on your homework. Assignments. And I need to add 3.5, so let's go ahead and do that. And there is 3.5. So 3.5. And I'm just going to pick a question, one that I might think should be on the test. I'd like to find some whole numbers. I don't like, there you go. So I'm going to blow it up. I don't know if I can blow this one up. I can't. So I'm going to put it on the Excel spreadsheet so you can see it. And we're going to find everything, just like we just did. So there is the numbers, and I'm going to blow them up for you. There you go. I got to put them in order. There you go. All right, I'm going to let you, give you 5 minutes and get do as much as you can with those numbers. Can y'all see those numbers okay? Because I don't know what y'all are looking at.
No, sir.
You can't?
No.
Okay, well, I will
We
call them out to you.
Great.
All right, 43, 43, 48, 48, 49, 50, 55, 56, 57, 57, 58, 62, 64, 65, and 68. So here they are. There they are right there. Maybe that'll help you. Is that better?
Yes, sir.
Didn't see that better? All right, give you, let's see, 8 minutes or 5 minutes would be, yeah, 253. Give you the 255. Do as much as you can. Does everybody have them copied down?
Yes, sir.
Okay. Mr. Latham, are you there? Or Miss Latham, are you there? Let me see a hand or something. Okay, good. All right, that's 2:55, so that's about 7 minutes. And I already filled out some little things, you know, nothing much. Just I did the median and the max and the minimum. So the mean is equal to the summation of all these numbers divided by 15. And that should be what y'all have. I really don't care about the mode, but what is the mode? Let's see. 57. Is 57 and 48 the mode? Y'all tell me. 48 and 57.
Yes, sir.
Range is equal to the highest minus the lowest. Mid-range is equal to the highest plus the lowest divided by 2. Variance to that number minus this number. And copy that down. And square that number. And copy that down. And all those numbers added up, I'm going to put that right here, is that number. And that is the numerator for your variance, divided by 14. And raise that to the 0.5 power. And there is your curve. So you take your handy dandy line. Here's your mean. Draw little lines. I'm not a good drawer, so I suck. Now you're gonna really see me suck when I do this. And there is your empirical rule, and it don't stop. So anyway, there's your empirical rule. Now let's fill in the number line. Well, half of, let's see, 43 to 55 is what? 12. Half of 12 is 6. So that'd be 49 right there. 6 right here would be what? 61. And then what would this be? 41 and a half or 44 and a half. And this would be 51 and a half or something like that. And this would be what? 55 to 61. Half of that would be 58. Something like that. And that is your box plot would be, let's go ahead now. How many numbers are above the 56? How many numbers are above the 56? 1, 2, 3, 4, 5, 6, 7. So you just pick the middle number, and that is your median, which is your first quartile. And that's equal to 48. Third quartile would be 62. And we'll color that. Running out of colors. That aqua color that we always use. And there's your 5-number summary. Interquartile range is equal to the third quartile minus the what? Minus the first quartile. And then your lower is going to be the first quartile minus parentheses 14 times 1.5. And the upper is going to be the third quartile plus parentheses 14 times 1.5. And look, our empirical rule says that anything above 78 is an outlier. Anything below 31 is an outlier. This one says anything above 83 is an outlier. Anything below 27 is an outlier. And that's it. That's all of, I think this is 3.1. This is right here. Most of this is 3.1 and 3.2. That's 3.1 and 3.2. And this is 3.5. All this right here is 3.5. The only thing we didn't do on this one is Z-score, and that's 3.4. Okay? Now, we'll show you one more thing before we stop today. Let me see what time, because I don't want y'all to start Yeah, we're good. We're good for about another 15 minutes. All right, so I want you to get your handy dandy calculators out. Get your handy dandy calculators out, and I'm going to show you how to do it. Now I'm going to use a short example and show you how to use your calculators. Y'all have calculators? Y'all allowed to use calculators or what?
Yes, sir.
Hello? Can y'all hear me?
Yes, sir.
Yeah.
Y'all have them, or you just don't have them with you, or what?
But most of us don't have any at all.
Say again?
Most of us don't have any at all in this school.
Oh,
Can we use them?
Yeah, I can get them for next class.
Okay, next time we have class, we can use them.
okay. Well, let me show you a trick learned in the war. you can actually, if you have a Droid phone, you can go to Wabbit, EMU, the app, Wabbit EMU, and you can download a TI-84 for nothing. Did you hear me? You can actually download a TI-84 no cost. And I'll show you what it looks like. If I can find it. Apps, Wabbit. And of course, I can't find Wabbit EMU when I want to. So let me just go to search. And I'm going to type in Wabbit. I'm about to lose it. Hold on a second. My phone is writing in wingdings. Yep, that's what it's doing. It's writing in wingdings. I don't know why it's writing in wingdings, but it's writing in wingdings. Great. There it is. There is what it looks like. Now, I'm sorry, but that looks just like a TI-84, doesn't it? So you can actually download that on your phone. Or you can go to Apple, and you have to pay for it, of course. What a surprise. I think you have to look up calculator app or something like that. Anybody know of any calculator apps for your Apple phones? Anybody?
We'll have the next class.
Say again?
We'll have the next class.
Okay.
Correct.
Look it up if you can and see what you can find out. But anyway, that's a free download, and that's not bad for a free download. All right, here we go. If you have your calculator, write this down. You want to go to Stat, S-T-A-T. Go to Stat and Edit. When you go to Stat and Edit, that is the same thing as like the spreadsheet that I always use. Stat and Edit. If this ever comes up, I'll show you. Eventually, it will come up. Sometime in the near future. As we wait for the Smart View to come up. I'm sorry it's taking so long. There. So you want to hit Stat and Edit. And these two columns, usually these first two columns are going to be the columns that you use. So I'm going to type in 21, 21, 25, 26, 27, 28. Everybody with me? 21, 21, 25, 26, 27, 28. All right, watch what I do here. You ready? I'm going to go to Stat. Calculate. First variable statistic. L1. And calculate. And there's everything you need.
Whoa.
So what do you say to that?
Covered paper. That's cool.
That's a whole lot what?
Easier.
Makes you appreciate the calculator, doesn't it? All right, now what am I showing you? Well, look. X bar. X bar is what you want. You want that. And in this case, X bar is equal to 24.67. 66 repeated. SX is your standard deviation. Write that down because you're not going to know it if you don't write it down. And that's 3.011. And then guess what's below that? Your 5-number summary. Hit the down arrow. And there's your 5-number summary. So the mean is 24 or 21. First quartile is 21. The second quartile is 26. The third quartile is 27. And the max is 28. It will also draw your box plot. Okay? You can hit second. You can hit second. Y is equal. Hit the enter. Go over to box plot with the line in the middle. And click on L1, or it's already got L1, and hit graph. You may not be able to see it, so you hit mode, or I'm sorry, you hit zoom 9. And of course, let me get this out of the way. Hold on, Y is equal. Let me clear this algebraic out of the way. And go to X, clear that algebraic out of the way. Give me a second. And now hit graph. And hit zoom 9. Okay, it's supposed to be showing it. I don't know why it's not showing it. Let me do it again. Second, stat, enter, on. Oh, I didn't turn it on. That's why. Zoom 9. There it is. There's your box plot. So, you know, you can use a calculator, but a lot of the questions are not going to ask you calculator questions. They're going to ask you questions that you have to do by hand. But I will give you questions that you can do with the calculator so you can use the calculator so you can get used to it if you are not already used to it. Aprende? All right, what have we just done, y'all?
Sir?
What have we just done today?
3.5.
We just did 3.5. So that means Monday, what are we going to be doing in class? If you do not send questions, write that down. If you do not send questions, we will go over the test. No, we will go over a test. And it will look similar to your test. And I will assign the dates for the test and the chapter 3 homework. Because right now, everybody should be working on chapter 3 homework. You should not be working on chapters 1 and 2.
When is that due?
I have no idea.
Okay, that's all right. I just didn't know if you set a due date yet.
Where do you look to see when something is due? My lab's math tells you when things are due. Okay, who is not here today?
Jesse.
Last name.
Jesse Wild.
Okay, hold on a second.
Where you get too much grade now.
It's so important to remember that.